Hello viewers, today we are continuing with the normal grade series on the logarithm and indices 3. Today we are going to explore the relationship between indices and logarithm. The relationship between indices and logarithm. Yes. From what we know, which calculate we can use calculator to confirm, log 1000 e base 10 is equal to 3. Oh yes, it's equal to 3. Assuming this is the first one, number 1. Then we can change this to indices. Assuming we bring this 3 to be the index of this 10. Then 10 raised to the power 3 will equal to 1000. Also, log e base 10 of 100 is equal to 2. And we can bring these 2 to be the index of this 10. So that we are going to have 10 raised to the power 2 is equal to 100, as you know before. Number 3, you know that log 10 in base 10 is going to give you 1. As mean you record that in your calculator, scientific calculator. Also, bring this 1 to come on top of this 10. We have 10 raised to the power 1 is equal to 10. Of course, you know that 10 raised to the power 1 is equal to 10. Then, we will extend this to the log of 1 in base 10. Log of 1 in base 10 will give us 0. And it's going to correspond to what we know before, that 10 raised to the power 0 is equal to 1. As we have said before, that any number raised to the power 0 will give you 1. Fifth law of indices in our former series. Okay, in the 51, let us see what we can explore. That log 0.1 e base 10 is equal to minus 1. Are you surprised that it's moving in that order? Then, let's see. 10 raised to the power minus 1, we are bringing this to be the index of this. 10 raised to the power minus 1 is equal to 0.1. You agree with me? Remember that this number can be changed to become 10 raised to the power minus 1, 1 on top, 10 raised to the power 1, which is 1 over 10. And 1 over 10 will still give you something as 0.1. So we are sure 10 raised to the power minus 1 is equal to 0.1. Alright, but in all this, since we see that they are in accordance, they are moving the way the first one moves, is the way the second one moves, we continue to move like that. So we can generalize it and say in general, if log m in base a is equal to x, then a raised to the power x is equal to m. This is how we generalize form. In this case, whether it is in base A, or it is in base 5, or it is in base 10, like all we have done here, they are all in base 10. Base 10 is of course called the common base. It will give you the same way. It will give you the same thing. Like the log of a number can be changed to indices. And that becomes the relationship between indices and logarithm. That log m in base A, if log m in base A is equal to x, then a raised to the power x is equal to m. This can be used in working many calculations, especially when we are supposed to find log of numbers that we don't know. Let's go and see some examples. Let's take the example here. The question here says, write in index form and find the value of x. write in index form and find the values of x. Let's take the first question. The first question is log 125 in base 5. That's the first question. Log 125, 125 in base 5. This is a log we don't know what it is. So we want to go and get it because we have seen the generalization, we have seen the relationship between two of them. And what we need to do is to say, okay, let us call it something. Let's log 125 in base 5 be equal to x, for instance. If it's equal to x, can you now see that this particular equation now that we have formed resembles this? What do we do when we have it here? We brought the x here and put it to become the index of the base. And so we are going to bring this x here to put it to become the index of 5, the base of this log. If that is true, then we are saying that 5 raised to the power x is going to be equal to 125. I think there's no problem there. And we can solve the equation of indices as we have done before. And so we are going to say here 5 raised to the power x is equal to 5 raised to the power 3. Remember that 125 is 5 times 5 times 5 in different places. And so we are going to say that if the bases are equal, then the indices are going to be equal. If the bases are equal, they are 5, 5. So the indices are going to be equal. We cancel out the base and equate the indices. We are now going to say that x we are looking for is equal to 3. Remember that what we call x is the log we are looking for. That log 125 in base 5 is what we call x. What are we going to say now? Since we have already said that it is x, and after calculation we got the value of x to be 3, we are now sure that log 125 in base 5 is exactly going to be equal to 3. What does it mean? Actually, we substitute now. 5 raised to the power 3 will give us 125. That shows that that's the correct answer. So this becomes the correct answer to question number 1. I hope that is alright. Okay, question number 2. Question number 2 gives us something that has decimal, and that number is saying that we should find the value of log 0.001 in base 10. As usual, we want to say that we don't know it. Since we don't know it, let's that log we don't know, log 0.001 in base. Log 0.001 in base 10. Let it be y. And when it is y again, we are going to bring y to come as the index of 10. So we are going to say here 10 raised to the power y is equal to 0.001. Alright, what do we do next? Remember in all the laws of indices we did, there was no law that has decimal. So whenever you have decimal in your laws of indices, you want to work questions using it, change it to fraction. Therefore, we are going to have here 10 raised to the power y will be equal to 1 over, under the point it puts 1, 1, 2, 3, 1 over 1000. I've changed it to this, so into fraction. And so 10 raised to the power y is equal to 1 over 10 raised to the power 3. Yes, remember the laws of indices. We can also say that 10 raised to the power y is equal to 10 raised to the power minus 3. We have changed 1 over 1000 to become 10 raised to the power minus 3. Remember that it's coming from the x raised to the power minus a is equal to 1 over x raised to the power a. And so when it is in this form, I can change it to this form. When it is in this form, I can change it to this form. This 1 over 10 raised to the power 3 is in this form. So we can change it like this to make sure that the bases are going to be the same for us to cancel out. So at this time, what we are going to do is to see the bases are equal again. The bases are going to be equal. We are going to say cancel out the bases and equate the number, meaning that y is equal to minus 3. Therefore, we are sure that the question they ask us, which is log 0.001 in base 10, is equal to minus 3. Therefore, log 0.001 in base 10 is equal to minus 3. I hope it's very clear for number 1 and number 2. Then, question number 3 here says, write the values of. It appears as if the questions are not the same, but they are related. They want us to write the values of the following: log half in base 2 and log 1 in base 3. Question number 3, solution to the question. In number 3, we have log half in base 2. Log half in base 2. In the same way, we don't know what it is, and so we are going to say, let it be equal to something. We choose a letter, any letter at all. That is one of the uses of algebra. Let log half in base 2 equal to n. We use n this time around. If it's n, we are sure that 2 raised to the power n now equals half. 2 raised to the power n is equal to 1 over 2. Don't forget that using this law again, 1 over 2 can be written as 2 raised to the power minus 1. And so we are going to say 2 raised to the power n is equal to 2 raised to the power minus 1. Remember, according to the laws of indices, that if we come here and write our dividing line here, through our dividing line, the negative sign will go. That means we are changing that to 1 over 2. So, actually half is something as 2 raised to the power minus 1. This time around, we have the bases being equal. And as usual, we say the bases are equal, then the bases are going to be equal. We cancel the bases and face the indices where we have a calculator. Well, we have something to calculate. And so n is equal to minus 1. Therefore, we are concluding that log half in base 2 is equal to minus 1. Finally, number 4. Number 4 wants us to calculate log 1 in base 3. Log 1 in base 3. If we are calculating log 1 in base 3, let's solve it the same way we have solved the other ones. Solution to that question is we say let log 1 in base 3 be equal to m. Let us use small m this time around. If log 1 in base 3 is equal to m, it means we can change it to indices according to this relationship we've established. It means that 3 raised to the power m is equal to 1. Now let me ask you, how can we make this to be the same base? We have already said that before we solve the equation of indices, we are going to make sure that on the left hand side, on the right hand side, we have 1 base, and then we can have this index. Have you forgotten? What do? How can we change 1 to become 3? Your guess is just something as mine, and then 3 raised to the power n is equal to 3 raised to the power 7. I'm sure you can recall. And so they now have the same base. 1 is something as 3 raised to the power 7. Raised to the power 7 is 1. And so if the bases are equal, we're saying the same thing. The indices are going to be equal. Cancel the bases and equate the indices, giving us that m is equal to 0. Therefore, we are concluding that log 1 in base 3 is equal to 0. In a matter of fact, any number defined of 1, no matter the base, whether it's base 3 or base 10, whatever base is going to be false. Dear viewers, remember to follow us in this normal grade series. Normal grade series is a series devoted to grade school, grade 10, grade 11, grade 12, as the case may be. Any question you have in what we have done, please endeavor to make comments on my page. Ask the question, we get back to you. Please like and share. We will continue from where we have started in our next class. Thank you very much.